Krishna, Krishna Krishna, Hare Hare, Hare Rama, Hare Rama, Rama Rama, Hare Hare. Hare Krishna, Krishna Krishna, Hare Hare, Hare Rama, Hare Rama, Rama Rama, Hare Hare. Hare Krishna, Krishna Krishna, Hare Hare, Hare Rama, Rama Rama, Hare Hare. Jaya Gauranita, Jaya Gauranita, Gauranita, Jaya Gauranita, Jaya Gauranita, Jaya Gauranita, Jaya Gauranita, Jaya Gauranita, Jaya Prabhupada, Jaya Prabhupada, Prabhupada, Jaya Prabhupada, Jaya Prabhupada, Jaya Prabhupada, Jaya Prabhupada, Jaya
Yeah, so I'm afraid that because tonight I want to discuss something about the origin of life, and the other lectures have been given also had some PowerPoint presentations which I can show here on the screen. But for this I don't have a PowerPoint presentation, but I was planning to go through a chapter in my book called Rethinking Darwin in English. But I just realized that I don't have a PDF of my book in English. I have an InDesign document, and I'm afraid that my InDesign program is an older version than the document, so I cannot open my... So I have it here in Danish, so I might go, we might have the Danish text, but I still speak in English. I'll use the Danish text as a kind of a guide, something to go through it. And also I have some other, I found a couple things from the internet I wanted to show as well. Some things which I think are relevant. So the origin of life, if we ask adherents of modern evolutionary thinking, which probably will include most from the modern scientific theory or scientific community, or most members, at least definitely what's been taught in the schools and colleges and universities, and what is presented in most popular presentations, mainstream media and so on, is that life arose on the early Earth as a spontaneous combination of some simple chemicals, some simple chemistry, and it has then evolved from simple chemistry and gradually become more and more complex until it at one point gained life, kind of life-like properties, and from then on, evolution really took over, and ultimately, we evolved to what we could become here. So, but it's, in the materialistic theory of evolution, it's very clear that life is simply chemistry. When it really boils down to it, that's all there is to it. No. But we can propose. It's okay that we proposing ideas, proposing theories without ourselves getting psychological food. because actually the philosophical mind is open to that. The philosophical mind is always open to discuss the opposite position. Why not? If it's true that life is chemistry, then why should we not accept it? We should, at least if we are truth seekers, we should not shy away from any truth. So if the truth is that life is just chemistry, why should we put ourselves in some kind of delusion that it's something else? We have to be consistent. If we actually want to be truthful, we have to be consistent. So if it turns out we can demonstrate life is chemistry, well, I would accept it. I like it, I may dislike the conclusion, but my intelligence would have to, I would have to accept it.
But you still couldn't give up worshiping Krishna.
Maybe I couldn't, but I wouldn't be convinced about it. So ultimately I would give up if I wasn't convinced about it. If I was just, and following something just because, but didn't believe it, was not convinced about it. No, I'm a person who wouldn't be able to do it. That's just how I am. So
maybe I wouldn't do.
That's maybe why you were not worshipping Krishna before, because you were not convinced that you were. Actually, you were convinced that he didn't exist. So that's still the problem. So you see what the result is of this discussion. Maybe we have to be out. Maybe we have to be materialist or something within 2 hours from now. That's so be it. That's life. Which is just chemicals anyway. So in this chapter, I introduce it with a famous conversation by Sri Prabhupada. Prabhupada had morning walks in Venice Beach in Los Angeles with Sri Lalitanatha Maharaj, Dr. Singh, and other disciples. Dr. Singh was a chemist. And actually a student of a very famous chemist, Harold Urey, who got a Nobel Prize, and who was involved in some actually we will look at that, probably get time to look at some of what Urey was involved with. Very famous, what was presented as now scientists are actually creating the building blocks of life. They're almost there, now they're just about making life. Urey was actually the man behind it. He had a graduate student making the actual experiments, but Harold Urey was the one who was behind him. That was also the professor of Swadhamra, who was discussing with Prabhupada. So Prabhupada, he has this discussion with Swadhamra Maharaj, or Dr. Singh, chemist, professor of chemistry, and he says that if your science is so advanced, and if life is just chemistry, then why can you not create life biochemically in your laboratories? That's what and science means you have to demonstrate it. Science means you can demonstrate prove your theories. Okay, you claim it's like this. We claim, for example, there's a claim that water is a mixture of hydrogen and oxygen. So that's a claim, and a true scientist he will back up the claim by actually proving it. He'll pull you into your laboratory and he'll say, actually, here's hydrogen, here's oxygen, and then he, and over a spark, or a fire, then he'll combine it, and actually, lo and behold, actually, you get water. Or you can go the other way. You can take water and you can separate the water, electrolysis. Is that how to pronounce it? And then you have to separate them with one. The ene leder. It's the plus or the minus, we get oxygen, and the minus you get hydrogen. Actually, so that can be demonstrated. So similarly, if life is actually chemistry, you might be able to give us a chemical formula for life, and not only that, you should be able to go to the laboratory and simply mix it, and voila, you have life. But then Prabhupada asked, why can you do it? And then one disciple says, we'll do it in the future. And Prabhupada, of course, he jumps on that and said, that's not science. You cannot say, the proof is that we'll do it in the future. If science means if you can do, you have to do it now, not in the future. This is simply nonsense. It's just a way of dodging the issue. Then at the same time says that just on the verge of creating life, and probably also process, that's just the same thing. It's just saying in the future in a different way. You try to wrap in some, little more, nice sounding words, but it's the same thing. You can do it in the future, but we want it now. And so he pushes on that point, and actually says it's like paying with a post-dated check. I might say, actually I'm a great millionaire, so I'd like to have this car, this fancy luxury car, and then you would say, if you're a car dealer, you say, okay, so that's $1 million, and I'll say, yes, I'll pay you. Here's a post-dated check. Here, it will be it's post-dated 10 years from now. Take it. But then say, what? But, okay, I don't have money now, but I will have it in the future. I will have money, so now you get a post-dated check, and I'll have the car. So probably, no, that doesn't work. This kind of post-dated checks arguments have no value. Science means you have to demonstrate now, otherwise just admit you don't know. That's simple. At least you don't know. And that's a fact. I mean, they might say that life is chemistry when they're pushed. They have no idea what the formula for life should be, nor can they actually create life in their laboratories. So actually they do not know if life is chemistry or if life arose as a spontaneous chemical reaction on the early Earth. That's kind of the gist of the Prabhupada. Prabhupada said that in 1973, I think it was, and of course many years have passed since. Now we actually are in the future. So we will see here. We'll have a look at where actually the state of the art, the up to date, where is the actual research into the origin of life, into the chemical origin of life. Of course, let's backtrack a little first. Let's see here. I think this is not going to. No, this English is not going to work. So I'll just stick to it in English. No Danish up there. And if we backtrack, we go back to the time of Darwin. And Darwin published his Origin of Species. Actually, he doesn't discuss the origin of life as such. His starting point is life is already there. He assumes there are already some very few simple life forms, or one simple life form, and then he kind of hypothesizes how life could have arisen from one simple life form. But he doesn't discuss the origin of life there. He says that there's a couple of letters where he mentions something about the origin of life. One letter he says that, it makes no sense to discuss the origin of life. One might as well discuss the origin of matter. The point is we have no idea, and it's just there. But then there's another letter where where Darwin he kind of fantasizes about that. What if at one point there was like some ponds, near some volcanoes, and there were all kinds of different kinds of chemicals.
Something like a primordial soup.
Yeah. With around some volcanic active area where there's different kinds of nitrogens and different mixtures in a pond. And then what if life could arise from there? He kind of said, maybe life could have arisen that way. And that was, at least it reflected I mean, there's nothing specific about that. But it reflected an idea that Darwin and many had in his time, many scientists had in his time, actually life was somewhat simple. And with the right conditions, life could just arise like that, spontaneously. I mean, near a volcano or lightning hitting some water, and then there was a life like that. And that was a prominent, the spontaneous generation of life was a prominent idea in the 1800s at the time of Darwin. So much so that there's a funny there's a funny incident in a decade or two after Darwin. There was the British Her Majesty's ship Challenger, I think it was called Challenger, was a big ocean-going ship that's actually research ship. It was actually, I think it was for the first time scientists, they started actually making research into the oceans. So that ship Challenger is kind of very famous historically. So, and they made many discoveries on the voyages on the Challenger. And one of the discoveries was at one time they pulled up from the North Sea out here some kind of a very peculiar looking mud. Mud. They pulled up some mud. Yeah.
Earth with water.
Yeah. And which looked, I mean, it wasn't life, but it looked very, you can almost see it living. And actually,
of the sea?
out from the bottom of the sea, from the North Sea. And actually, one famous scientist, Thomas Huxley, he investigated. Actually, this is the primordial life, and he even gave it a Latin name called. It's here something. Batrubio's Hackeliae was a Latin name given to this new species that they had discovered, and it went on for some years. That it actually appeared, in the trees of lives that were being drawn in those times. They started with this mud, and it lasted for something. It says here 7 years. It lasted. And then it was actually discovered it was just some inorganic, it's called precipitate. Is that the word, how you pronounce it? Bundfald. So it's just settled, some inorganic.
Precipitate.
Huh?
Precipitate.
Precipitate, yeah, that's how you pronounce it. So, I mean, settlements, just natural form of settlements, and has nothing to do with life as such. So that was it's kind of, some scientists really call this as a great discovery on the origin of life. So, but then there's, so that was kind of in the 1800s, this idea of a spontaneous, immediate generation of life was kind of prominent. But then as we enter the 20th century, scientists can start understanding actually, I mean, whatever life is simply incredibly complex, like a cell. Because that's also one thing that Darwin thought, that the cell was something fairly simple, something like a microscopic drop of slime or something like that, on mucus, something quite simple. But actually, as they advanced, actually started discovering that it cannot be. It's cell is actually incredibly complex, and life is more complex than anyone ever thought. So then that also affected the theories about the origin of life, and scientists started hypothesizing about actually this process of generating life taking millions and hundreds of millions of years actually. Slowly from the some kind of primordial soup idea, where things are just cooking for millions and millions of years and become a little more complex and gradually building up. And then at one point, actual life arising from that process. The most famous of these scientists was a Russian named, what was his Oparin, Alexander Oparin. He's a scientist who lived from 1894 until 1980, and he was theorizing that again life has arisen over hundreds of millions of years on the early Earth, and the oceans, they were filled with some kind of simple chemicals such as ammonia, methane, hydrogen, carbon dioxide, and water vapors. And combined with ultraviolet light, some little more complex organic compounds arose, and they again became more complex over as time went by, until ultimately you get something that is life-like. So that's kind of the theories of the origin of life from the beginning, and from in the 30s and 40s and the 20th century. And still, of course, at that time, still at this time, scientists don't have really much idea about the complexity of life and cells and so on. But they get started to get a glimpse of how complex it is. And the start of understanding the real complexity of life is actually is kind of in the 1950s, and probably the most important marking points of kind of the new era of understanding biochemistry is in 1954, when two scientists, Francis Crick and James Watson, they get the Nobel Prize for having discovered the structure of the DNA. And that's of course very famous. And but actually in the same year, in 1954, another very famous biochemical experiment had taken place and had been published. And it was an experiment trying to confirm Oparin's hypothesis about simple chemicals such as ammonia, methane, and hydrogen, and water, and so on, creating the simple building blocks of life. And that was an experiment that was conducted, actually, as I mentioned, Harry Urey before. And he had a student, a graduate student called Stanley Miller. And Stanley Miller, as a student, he made an experiment with actually he took in a closed flask where precisely the chemical elements that Oparin he had suggested, ammonia, methane, oxygen, carbon dioxide, water, and then he circulated this mixture in a closed system for some days, and also circulated over an electrical discharge. And then after some days, then he would analyze what was the result. And amazingly, he actually found that amongst many of the other chemicals that have been created for this process, there were also amino acids. And that was really a big, I'm not surprised, but that was like a great jubilation. It was he concluded, Harry Urey concluded like that actually the building blocks of life can arise spontaneously, and this experiment was publicized widely. Scientists are creating the building blocks of life now. Actually, they're just there. Because amino acids, they're almost living. That's how it was presented. And the whole world, it was, of course, none of us were born in 54, and back in 54. But those who told me were back, it actually made a really big impression, because it's kind of really gotten through action now. Of course, we already knew that evolution was a fact like that, but now we're really proving it. Now we actually are creating life in our laboratories. Here it is from this. For example, what you see there here, this text is from Time magazine, where they explain that how the candidate student Stanley Miller, 23 years, he was only 23 years old at that time, told how he simulated the conditions on the primitive Earth and created out of its atmospheric gases several organic not connections in chemistry, combinations, compounds, which are very close to proteins, and so that was how it was publicized all over the world. And at that time actually it was, and scientists now we're really close to creating life or demonstrating how life could arise on the early Earth. Of course, if we jump forward, if you go to a book like 50 years later, I have it up there, if you see there's over 50 years later, that paragraph. There's a quote from a book called Life Solution from 2003 by a British scientist called Simon Conway Morris. He's a very famous, world-famous scientist actually. And he had a chapter in that book about research into the origin of life, where he started the chapter saying, this is a chapter about, or this is a story of an abject scientific failure.
What?
Abject scientific failure. Abject, ynkelig, miserabel, og også lidt fuldstændig pinlig. This is
the awful failure.
Yeah, embarrassing failure. This is of a completely embarrassing failure. So what happens, after these 50 years from 54 until 2003, was that, well, several things happened. One thing was that it was discovered that maybe you could generate amino acids in laboratory or under natural conditions simply, but actually it stopped there. You don't get anything spontaneously arising there naturally on its own. And at the same time, for every year and every decade over those 50 years, scientists have just been uncovering more and more amazing complexity, biochemical complexity in